British Columbia Oil and Gas Commission. I'm the Vice President of Applications. So in my role, essentially any oil and gas related permit or authorization, and we cover quite a gamut, I'll talk to that, would come through people that report through my groups. We also have different portions of the commission that are focused on compliance and enforcement, so on the ground inspections. And then we have a whole engineering group that really is focused on oil and gas related engineering and standards development. We have subject matter experts, whether they're environmental, regulatory, policy, that type of thing, all of which support either the issuance of permits and authorizations or the on-the-ground compliance assessment. When I was asked to speak here today, and again, thanks for the opportunity, I tried to complement Jocelyn's presentation, so I did get an advanced look at hers and tried to complement that with the regulatory side of what she was speaking to. I haven't covered all of the subject matter she has in the same depth with the regulatory side. And I've picked a few topical areas. Each one of these topical areas we could spend a whole day on if you wanted to dig into it deeper. And there certainly are areas related to oil and gas development in the Northeast that, or in the province for that matter. So just a few things I'm going to cover. I wanted to cover a bit more about who the Oil and Gas Commission is, because we're not all that well known outside of the northeast of the province. A little bit of a primer on BC's unconventional gas development. Talk about water use, again, following along Jocelyn's presentation. Contamination risk, talk a bit about that. Induced seismicity, so the potential for creating small earthquakes. And finally, a little bit, maybe it complements Gary's presentation on some of the land-based aspects and cumulative effects assessment. I'm not going to go into that in too much detail because there's really a lot of work that's happening now. So there's nothing that's completed that I can talk about. But yeah, feel free to ask as we go. So the BC Oil and Gas Commission, as I said, we're not all that well known outside of the gas producing and oil producing parts of the province. But we were established as a Crown corporation or a Crown agency a little over 20 years ago. We're an independent agency. We don't actually report to a minister or ministry of government. We have a board. There are some similar agencies in the province like WorkSafe, Technical Safety BC, those types of entities that operate similarly. And we were created to be a single window regulatory agency, really for the upstream oil and gas sector. When we were put into place, the activity levels in the Northeast were picking up. Companies had to go to multiple agencies just to get simple approval to do a fairly small operation. So the intent with us was to create a single window where they could come to one agency and get all of the authorizations they need. And for the most part, that objective is met. Even today, companies rarely, if they're doing smaller upstream projects, don't need to go to anyone besides ourselves. When you're talking large major projects, that's certainly not the case. Most of those larger projects require an environmental assessment before you can even start to talk about doing any permitting. We're set up as a peer regulator, so we don't issue rights to the resource. So tenure rights, those are issued by the Ministry of Energy, Mines and Petroleum Resources. We don't set royalty rates and collect royalties on behalf of the province. So we really regulate the activity of oil and gas development. We don't consider ourselves the province's policy maker. When you're talking about broad policy around economic development, environmental management, that type of thing, we consider ourselves a policy taker. So we implement the policies of government. We don't set policies. We do have some ability to make our own regulations, but those are largely technical in nature. They're not about value judgments that government tends to make. And finally, we don't operate on a budget allocation from government. We're a fee-for-service organization. So our entire revenue is derived from application fees, annual fees on infrastructure, and levies on oil and gas production. We operate throughout the province, and our mandate covers the entire province. And we've always regulated oil and gas activity outside the Northeast, particularly with large transmission lines. But suffice it to say, the bulk of the oil and gas activity we regulate occurs in the Northeast. And we have offices in Fort St. John, Fort Nelson, Dawson Creek in the northeast, as well as offices in Kelowna. It's kind of an engineering hub for us. Victoria is more of a corporate office. And then with the recent LNG related activity across the north, we do have staff both in Terrace and Prince George. So the way our single window works is we have a parent piece of legislation, the Oil and Gas Activities Act, that really identifies what is an oil and gas activity, and it's very broad, everything from exploration, production, processing, transmission in pipelines. We also have authorities under a bunch of other provincial legislation that would normally be administered by other agencies of government, but if you require an authorization under the Land Act, the Water Sustainability Act, the Forest Act, or there are other enactments like the Heritage Conservation Act, the Environmental Management Act, et cetera, you require an approval under those acts and it's related to an oil and gas activity, then it's the commission that deals with it and not the agency that normally would administer that legislation. And so really the authorities we have under the Land Act are about authorizing use and occupation of Crown land. The Water Sustainability Act, it's really allocating water for oil and gas development. The Forest Act is authorizing the harvest of Crown timber to facilitate the building of a well pad or a pipeline or a road. And then the other enactments we have are the Heritage Conservation Act is dealing with potential impacts to archaeology resources. And the Environmental Management Act, we issue permits for air emissions and waste discharges. BC, and I'll talk a bit about the transition, but BC really is a gas province. We don't have much for oil resources. The production of oil is quite small in relation to gas production. It's not really increasing or declining, but we do have some major unconventional or shale gas plays in the province, and they're world class, particularly the Montney play where most of the activity is occurring now. But we do have the Horn River that Jocelyn talked about in the very far north, as well as the Laird and the Cordova. None of those northern gas plays are very active these days, and it's really in relation to the cost of extracting gas in those areas and the fact that they're really dry gas. They don't have much gas liquids in them, and it's really the gas liquids that at current gas prices that makes gas production viable economically. So the Montney play does have gas liquids, not all of it does, and it's really the liquids-rich areas that are active these days. So we saw a very rapid transition from what was called conventional oil and gas production to unconventional. So it really occurred in the period from 2007 to 2011, 2012, where in 2007, 85 to 90% of the wells being drilled were conventional. There were a few unconventional wells being drilled. And then over a period of 4 to 5 years, that turned completely around. And that trend has continued to the point that there are virtually no conventional gas wells being drilled anymore, and all of them are unconventional gas. And virtually all of our production has followed the well drilling. So now we're at the point where most of our current gas production comes from unconventional wells, and that trend will just continue. This is the classic conventional well drilling. It's a single well on a pad, roughly little under 1.5 hectares. To what we have now, which are the multi-well pads, anywhere from 3 to 10 hectares, 10 to 30 wells. We used to limit them to 26 wells on a pad because there are only 26 letters in the alphabet, but we've gone past that now. And we even had one company proposing a 50-plus well pad. They didn't end up going through with that, but that's the trend that the industry's been on. Increasing number of wells per pad, fewer well pads, and some pretty sophisticated drilling of the unconventional zones. So I wanted to cover water use. I know Jocelyn talked about it in detail, but when we think about water use and what we regulate, it's the entire water use cycle, right from original diversion or procurement of water resources, the transportation, storage, and use particularly during the completions phase of the operations, recycling and reuse, which is a real focus area for the industry for a few reasons. And then finally, when the water can no longer has a use, it's disposed of. We regulate all those phases. So the key principles that we operate under, and we're operating under provincial enactments, the same enactments that other agencies use when they allocate and authorize the use of water resources in the province. But what we're looking for in surface water diversions particularly, or those groundwater diversions that are linked to surface water sources, that we need to protect environmental flows for aquatic life and wildlife. So there's a whole policy around what is an environmental flow need of a stream or a system. We need to protect the current and future needs, domestic use of water or community use of water, so that's a priority. It would certainly supersede any industrial use of that water for oil and gas purposes. We want to understand the natural variability in water availability, especially surface water, and how that varies over time. We need to be able to respond to low flow conditions, whether it's seasonal low flows or periods of drought. And we've put a lot of effort into being transparent about water use by the industry and what we allocate. So we do a fair bit of reporting. We report on a quarterly basis. That's publicly available. And then we spend a lot of time collaborating and coordinating with other government agencies that deal with the same water resource, particularly the Ministry of Forest Lands and Natural Resource Operations and the Ministry of Environment. So water procurement and use, we're seeing quite a trend, especially in the southern part of the Montney. And again, back to the map, the Montney formation is where almost all the current oil and gas activity is happening these days. And it runs on a kind of a northwest-southeast trend, north of Fort St. John to south and southeast of Dawson Creek. We are seeing quite a trend to water storage reservoirs. And really that's a reflection of needing to have water available through the year, but we're wanting to limit the diversion of that water to periods when there's a high availability and not put stress on systems when water flows are low. We see a wide variation in sizes, everything from small dugouts to things that qualify as dams and even what are called regulated dams. So they're regulated under the province's dam safety regulation. And again, we are working very closely with our colleagues at the Ministry of Forest Lands and Natural Resource Operations because some of the oil and gas water use is not regulated by us. It occurs on private land by private operators. We regulate the industry more or less, although we do some work on private land. But then there's a complementary set of regulation that must occur for those entities that we don't regulate. Transportation, storage, and use, again, it's a big function in unconventional oil and gas development for the industry. And the industry has really evolved from the early days, the 2011, 2012 period to today. There's some very sophisticated water procurement, water transport, and reuse systems in place. So we're seeing the industry evolve to fewer diversion points from larger systems, and I think that there's certainly an environmental advantage to that. We're seeing more transport of water, not just fresh water, but flowback water in pipelines rather than trucks. There's an advantage to that, obviously, from an efficiency viewpoint, but there's also an advantage to the local residents with truck traffic. In the days that it primarily was transported by trucks, there were literally thousands of truckloads of water moving on an individual road system over a year. That's changed significantly by moving water in pipelines. And again, the flowback water is also being moved in pipelines, so it does enhance reuse because we see companies, I got a picture of one, that have actually put in large, sophisticated water hubs that both receive and move and mix water to wherever they need it. Flowback water management is a big and very important part of the water use life cycle. So again, significant volumes of flowback water, that's water that comes back up the wellbore after the fracturing treatment. They need to be handled not just for potential disposal, but more importantly and more often we're seeing that that's being handled and managed for reuse. If it's not going to be reused in the province, it must be put into a disposal well and into a disposal reservoir. And we currently have no instances of treatment and reuse. Although we do have some companies talking about that, it has not been an allowed practice in the province and won't be until the province is satisfied it can be done safely. This, you see at the bottom part of the screen, is a flowback storage pond. Some of these can be quite large, similar to a freshwater reservoir or dam. And there's some very strict requirements around those ponds for obvious reasons. They have flowback water, it's contaminated, it's briny water, very salty, and it can have hydrocarbons in it. That part of it we don't allow, if it's pure hydrocarbon or hydrocarbon contaminated, we don't allow storage in these ponds. They must be engineered and designed by an engineer, and the construction certified by an engineer. They require an impermeable clay base and then double synthetic liners with leak detection between the liners. And they also require a monitoring system. So a built-in monitoring system to detect leaks and to assess any water that's coming out or potentially coming out. They also, if they have the potential to impact wildlife, they require fencing, or if birds may be landing on them, they require some kind of a deterrent for waterfowl to be landing on those ponds. And finally, we do limit the amount of time that they can store flowback water in a pond or an open containment like this, so it is time limited. And finally, the disposal phase, it's regulated by the Oil and Gas Commission as well. You have to have subsurface rights to operate a disposal reservoir. Those rights are issued by the Ministry of Energy, Mines and Petroleum Resources. And then if someone is proposing to use a reservoir as a disposal reservoir, it's assessed by our reservoir engineers. And what we're looking for is that that reservoir will contain the fluids. They won't migrate elsewhere. Most of the disposal reservoirs are really just depleted oil or gas reservoirs. So we have history of reservoir, of how the reservoir was when it was originally used for oil and gas production. We also require assessment and testing of the well being used for disposal, and it's often a repurposed oil or gas producing well. And then we have instituted restrictions on the pressures they can use when disposing down the wellbore, as well as a cap on the reservoir pressure, so they don't continue to put disposal fluids into a reservoir and build the pressure past what the reservoir can contain. And then there is an ongoing monitoring component and reporting component where we do verify that the disposal reservoir is functioning the way it's supposed to. The sources of water for hydraulic fracturing, and this is dated, and there are some estimates in there because it's very hard to do a full mass balance assessment of water use, for the simple reason that, for the complicated reasons that you can't just pick a period of time and go and measure what was authorized for diversion, what was reported as diverted, because companies divert water and store it for a period of time and use it at a different time. We don't know exactly how much flowback water is water that originated from the fracturing operation and what of it is produced water from the formation. There are some sources of water that weren't regulated and aren't currently regulated, but are falling under regulation now with changes under the Water Sustainability Act. But just picking a short time period like a year, you have a lot of things that are potentially out of phase with each other. We could probably do a better and more accurate job of that over a longer time period, and that's the type of thing we are looking at. So this is really probably an example from 2015-16. So there are some differences we'd see today. But in that period, we determined that about little under 50% came from surface water sources, so either water licenses or short-term approvals. And then from there, about 35%, I think it was from private acquisition and or produced water. And it's very hard to determine which of which there is, just because of the uncertainty around how much is produced versus flowback versus et cetera. We also have some other sources, so water source wells, and those are groundwater wells that are authorized by the Oil and Gas Commission. We've authorized groundwater use through water wells for really probably since our inception. For some time now, it was the only actual authorized groundwater use in the province for a long time, until the Water Sustainability Act came in. But it's a pretty minor source of overall water use for fracturing. We also have some deep saline wells that Jocelyn talked about. The Horn River had a fairly large DeBolt well that had saline water that was being used for fracturing. Now that the Horn River is pretty much inactive, that source isn't being used, but similar sources are being used in the Montney. There isn't the same availability of saline, deep saline sources in the Montney. It does occur in some areas, but not in others. And then finally, we do have some other examples. Shell and the city of Dawson Creek partnered on a new water treatment plant, and part of the reason Shell was involved in that is they wanted to use some of the municipal wastewater rather than having fully treated wastewater coming out of Dawson Creek's water plant. They built another plant that could treat the water to a usable standard, and they were using that as using that in industrial operations. When Shell began to ramp down some of their operations in Canada, was using that water. It's not a large source of water, but it is an example of some innovation around using water sources. And both the city of Dawson Creek and the city of Fort St. John have historically sold water for industrial purposes that's surplus to their needs. How much water is used? And this is a bit dated. It's looking at 2012 and 2013. The reason I wanted to put it up there was to show that there's a big difference, and Jocelyn talked about, there's a big difference in water use for fracturing dependent on the geology. So if you look at the Horn River, which is more of a shale gas formation, a much harder rock, they were in this 75,000 cubes per well, even up to 80,000 cubes per well. And at that time, the Montney was about a tenth of that. And you can even see differences between the Heritage Montney, which is the southern part of the Montney, and the North Montney. The Heritage Montney used quite a bit less. We are seeing some differences now. Some companies are actually using more water in the Montney than they did historically, but the reason they're doing that is they're getting a corresponding increase in production. So overall, if you're looking at a finite production level, which they are capped by their ability to process gas, they're drilling fewer wells and using the same amount of water to get the same amount of production. We are attempting to assess on a year-to-year basis water use per unit of production and see what the trends are. The only problem is when we've done that, the period of time we were looking at was the transition from companies moving out of the Horn River, so that kind of skewed some of the results. But as we go over time, we should be able to get some kind of a rough estimate to see if overall water use per production is declining, growing, or staying the same. So going back to, again, this parallels some of the discussion Jocelyn put out there, but looking at the annual runoff, so water use in comparison to the availability of water in the Northeast, and this is looking at the Montney. So of the 61 billion cubic meters of water that runs off annually in the Montney, about 0.07% of that was authorized for oil and gas use, really for fracturing operations. And then of that, about 0.008% was actually used. We see a pretty standard trend that we authorize X amount of water, companies use about 10% of that. And the reason for that is we do assess what they are asking for, but we authorize it over a period of a year or 2 years or even a 15-year period in a water license. We know they don't use it 365 days of the year. They probably use it for actually only a few days a year. But if we can find that diversion to the days we thought they were going to use it and there was any kind of a change to their plans, we'd be constantly having to revise that. Right now, we're not seeing an issue with the amount of water we're authorizing, and we do know that they're not using anywhere near that anyway. When we do assess any kind of water application, we look at it in the context of everything that's been authorized, whether it's for oil and gas purposes or not. And that's part of the environmental flow need assessment. And equally so, if another government agency looks at authorizing water from a particular system, they would look at the authorized volume for oil and gas, not the estimated use. So a few of the water current challenges and responses to those challenges. So one of the things, again, that's the key priority for us when we authorize water and see it used for oil and gas activity is we want to make sure it's available for priority uses, and that is firstly protecting the aquatic and wildlife use of that water, and then secondly having it available for domestic and community use or agricultural use. So that's where the assessment of the environmental flow needs comes in. It's a requirement under the Water Sustainability Act. It was something we were doing and others were doing before that became a requirement. And really what, as a rule of thumb, we will not allocate or see allocated any more than roughly 15% of the available water in the stream. So leaving 85% at all times for the integrity of the stream. We don't see ourselves getting anywhere near that in any of the systems we authorize water. We're usually in the 1% and 2% range. And again, that's looking at not just the oil and gas use, it's all authorized water in that system. And we report on this annually. It's available. I'll have a slide on that. We do limit the use of water seasonally. So we have a lot of systems in the north, especially the smaller ones that have very low flows in the wintertime. So we limit the water use to periods when there is more flow in the stream. And we also have the ability to suspend use during drought periods or low flow periods. And we've done that probably, well, more years than not since 2010. We did it in 2010, 2012, 2014, 2015, 2017, and last year. So that we suspend water use for oil and gas purposes in some or all of the Northeast, depending on where the drought conditions occur. Water transport and use, again, as I mentioned before, we're seeing greater use of pipelines. So that significantly reduces impact on landowners and residents and people using the areas where oil and gas is occurring. It's also likely reduces some of the risk around spills. Again, back to what we know about pipelines versus non-pipeline transport of oil and gas. It'd be the same for water. It's not zero risk, but there should be less risk with pipelines than transporting on roads and using trucks. And finally, this is an example. I believe this is in Canada's water hub in the Montney. But these water hubs are very sophisticated. There's a lot of money and planning goes into them. And it's really about being able to efficiently move water around to their operations, which really does promote reuse. And it's almost, as was mentioned earlier, a bit of a closed system. On the disposal front, we are seeing some impacts on disposal capacity. So some focus on ensuring we have sufficient disposal capacity. And part of that is driven by the limits we put on reservoir pressures. That immediately began to limit some of the available disposal capacity in reservoirs, and some had to stop disposal of reservoirs and seek new sources of disposal. It will be a greater concern some decades down the road as the main development phase of whatever gas play you're talking about, whether it's the Montney or another one, once they start ramping down from the main development and completion period, then there'll be more water that needs to be disposed of. There is a real economic and environmental synergy with reuse versus disposal. So if you think about the cost of acquiring water, new water and diverting new water from new sources, it's expensive. It's expensive to transport, and it's expensive to dispose of. So there is a real incentive for the industry to reuse water, and we're seeing a lot more reuse. If I go back to that chart about the sources of water, I think we had an estimate of 30-some% reuse mixed between private acquisition and reuse. I don't know what the numbers are for reuse, but we've seen a trend of increasing reuse of water, and that should continue. And finally, around the public concerns about water use and risk of contamination, we put a lot of effort into transparency. I've talked a bit about that. There's a lot of work being done, research within the province, really around the risks of contamination and other things like not just fluid migration, but gas migration and things that have been experienced both in BC and other jurisdictions. So FracFocus, I won't get into it, and Jocelyn already covered it. It was actually originated in the US. The commission brought it into Canada and licensed it in Canada and made reporting through this system a requirement in our regulations. I believe it was 2012 or 2014. No, there's a lot of work done together with BC and Alberta particularly, and part of the reason is we want to benefit from each other's knowledge, but the other is we regulate largely the same groups of companies. And it's from a compliance perspective, there is a real benefit that they're not seeing fundamentally different regulatory requirements in one jurisdiction to the other. They build systems to comply, and if they're seeing the same regulations in both jurisdictions, it's easier for them to set up their systems. And this is just an example of what you'll see in the menu if you go into FracFocus. Jocelyn talked about it. You can go in and query any well you want to in the province and find out a number of parameters around the well, whose well it is, when it was drilled, what the completion fluids were, and you can look up, or do whatever you want with that information. We've talked about further enhancements around collecting water volumes and so on, and so you may see even more information as time goes on. Currently it's focused on allowing people to understand what was used as far as fracturing fluids. Put out quarterly and annual water use reports, and they look something like this. They really talk about how much volume was authorized in short-term approvals and in water licenses. It's done by basin, sub-basin, and then rolled up into a whole. And we do look at total volume authorized and total volume used as a percentage of mean annual runoff. So you can get a feel for how much water is being authorized and used in comparison to how much water is available in that system. And as I said, in most cases, the numbers around authorization and use as a percentage of the annual runoff are very, very low. They're in the below 1% in most cases. We do have some systems that have a number of different uses, whether it's agricultural or community, and they're smaller, lower water availability systems. They're quite a focus for us, so they tend to be associated with the Southern Montney or the Heritage Montney, and they often have community uses. So that's a real priority for us to focus on ensuring water is not overused. In those systems, what we usually see are water diversion is only allowed in the spring freshet period, and then if they need that water through the year, they need to build storage structures. But we have what's called the Northeast Water Tool, and there are similar tools throughout the province. We can determine, based on historical records, what the mean availability of water is in those areas by subbasin, and then compare it to what's already allocated or authorized, and then be able to look at the difference. If we're talking about a water license, so a longer term, and we don't issue perpetual water licenses, ours are from the 15 to 20 year max period. we would require more original hydrological data to be collected supporting the application. We don't simply rely on Newt because it has some limitations. So this is essentially the same slide that Jocelyn put up, but all I wanted to illustrate was there's been a tremendous amount of research on hydraulic fracture propagation and its potential ability to reach the surface or the near surface. And so this one is from the Barnett. If you look at the majority of fracture propagation vertically is relatively small in comparison to horizontal fracture. But
to add, like, those larger spikes you see in the propagation, that might be where a local fault was propagated.
The spikes are likely associated with faults, but even then, long ways from what we know of the base of freshwater. And so this is American, it's in feet, but we plotted the Canadian metric system here. So 1,000 meters, 2,000 meters. The Montney, roughly 1,500 meters, and I can show it. The Montney starts at about 1,500 meters, but the actual fracturing in the Montney would be a bit lower than that because they don't fracture right at the start of they're deeper into the zone. But again, in BC, we're operating more on this end than this end for sure. And then the same from the Marcellus, essentially showing the same thing. And scientists like their statistics, so they say that there's greater than 99% confidence that hydraulic fracture below this depth will not intersect a freshwater aquifer. You will not get a scientist that says there's absolutely no chance. But that's a pretty strong identification of low risk.
And on top of that, all those fresh groundwater aquifers are monitored around that fracture planning zone with pressure trends.
Basin depths we're talking about, so the Montney is 1,500 to 3,500. Cordova is similar. The Horn River is deeper and the Liard is deeper again. So if you're talking about risk in BC, at least as far as what we know about shale gas development in the current formations, we're definitely on the lower end of risk, even though even on the opposite end, it's not felt that there's a plausible likelihood that you're going to intersect potable groundwater. It is different with coal bed because they tend to be quite shallow depths. And we did have some coal bed development in BC, but that stopped.
So to address that, do you want me to address
go ahead.
So coal bed methane is still, it's not really active right now. There's a couple areas in Alberta that are active. You cannot fracture coal bed methane with water or sand or additives. The only thing you can complete coal bed methane with, because it's so close to the surface, is pressurized nitrogen. So pressurized air, basically. So what they would do is pressurize air and pump it into that coal seam, and it breaks up the coal, and that allows you to get the natural gas out faster. So above, I think, 650 meters in Alberta, the only completions that you'd usually see are pressurized nitrogen, and that's on coal bed methane.
That changed in 2014, 2015.
Yeah. Before that, they were using these split systems called like Clean Tech and FracClean. Those were microtox or, I believe, compliant. So that's not regulated category we're talking about.
Just a quick one on coal bed. We did have some coal bed development in Hudson Hope area, so near Fort St. John. That ended almost a decade ago now, and a little bit in the southeast of BC, but everybody that's looked at it said they don't believe that it will be economically viable for the foreseeable future, so you won't see any activity in that space. So again, this question has been studied in a number of, especially looking at, the Canadian Council of Academies did an assessment of hydraulic fracturing and fracturing risk, concluded that there's no known case of fluid migration into potable groundwater. There are others that say it's unlikely or that it's not physically plausible, but no one will come out and say that it can't happen. There are theoretical pathways to people's point. but there's been no examples of that ever playing out in the real world.
Just for context, how many wells is that in BC? How many wells are drilled? When you say there's no known examples, how many wells are we measuring that against?
In BC, I think we have around 30,000 wells, of which half are active. As far as a jurisdiction with a history of drilling wells, we're probably well behind Texas or Alberta. They've had a much longer history and a lot more wells to go on, and they're not seeing it either. But I think, again, there are including various assessments of hydraulic fracturing risk and particularly fluid contamination, including the most recent one done in the province. I don't want to speak about that too much because the province is preparing its response to that scientific panel report. But the BC report concluded the same thing. You can't rule it out, but it's not viewed as a significant risk. A greater risk is likely contamination from spills of fluids and flowback water at the surface. So handling that water, not hydraulic fracturing subsurface per se. So induced seismicity is not new. It has been linked to disposal wells for decades, since the 80s, both in BC and elsewhere. And really, we have over 100 active disposal wells in the province. Of those, 4 were linked to induced seismicity. 2 of those have ceased operation in 2015, and the other 2 are being managed through mitigation requirements. But again, it's not a new phenomenon. It has been associated with disposal for those period.
Unknown participant is now joining.
And the mitigations that we've applied to disposal, I mentioned before, is limiting pressures, so disposal well bore pressures, as well as the overall pressure buildup in the disposal formation. Hydraulic fracture-induced seismicity, to our knowledge, we are the first jurisdiction to make the link between hydraulic fracturing and induced seismicity, and we did that in 2012 in the Horn River. We produced a report that identified a pretty definitive correlation between hydraulic fracturing and induced seismic events. Up until that time, the belief in the industry and amongst the regulatory world was it was definitely a possibility with disposal, but not with hydraulic fracturing. We concluded differently in 2012. We did a follow-up report in the Montney in 2014 that concluded the same thing, and now it is accepted pretty much in all jurisdictions that there is a definite ability for hydraulic fracturing to induce seismicity. Looking at the period, and this was a reporting period that we had, so August 2013 to December 2015, 26,000 fractures, 358 we had recorded events on the national seismic detection grid. So about 1.5% of fracture activities generated a seismic event. We've had 17 induced events greater than magnitude 3, and in Northeast BC, so 4.7% of seismic events, or 0.07% of overall fracture activities would generate something greater than 3. We've had 2 induced events greater than 4 in that period. So again, as a percentage of seismic events, small. As a percentage of fracture operations, much smaller. So again, the point is that seismic events from fracturing occur infrequently, and higher magnitude events are rare, but they do occur. The other key that we've identified is that the duration of these seismic events is quite short. They're not like an earthquake that can occur over a period of many seconds or minutes. They tend to be very short duration, and the likelihood or the occurrence of seismic events after the hydraulic fracturing activity is stopped is only a potential of a matter of days. So in that same period, and the same holds true now, we don't see the number of events, the magnitude of events, correlate with the amount of activity. It's really a reflection of where the activity is occurring in relation to what are called critically stressed faults. So in that period there, again, we had X amount of activity, and some short periods in that overall period, there was very little activity, and some there was a concentration. It was really about where that was occurring in relation to the seismic potential. We are able to map faults, so that's a well understood process in collecting geological information. The problem we have, we don't have the predictive ability of identifying which of those faults are critically stressed, which then have the potential for seismic activity. We're really learning that through experience. So we do know if someone has drilled and completed in a critically stressed fault and we have a seismic event, we do know then that that's a critically stressed fault. But before that, we don't have the ability, or a very good ability, to proactively identify that. So where are we focused now? So in the period 2014 to 2019, we're focused on hydraulic fracturing in the Montney. If you look at the event count in that period of events greater than magnitude 3, we had 47 and 4 in magnitude 4. All of the high magnitude, so the greater than 4, were hydraulic fracturing induced. If you look at the other sources, so EOR is enhanced oil recovery. We have an enhanced oil recovery program in the Fort St. John area that's historically generated some seismic activity. But we weren't not seeing, and it's partly the way it's now regulated, we weren't seeing seismic events 3 or greater from that source. Same thing with disposal. We instituted the mitigations. We are still seeing events, but we're not seeing high magnitude events. And high is relative in our world. A magnitude 3 is considered low, very low magnitude seismic event. But in our world, we consider it as something to be mitigated. We also have been focusing, and I'll talk about it a bit more, in the southern, so the Heritage Montney, for another reason.
Unknown participant is now joining.
If you look at felt events, so felt events were, in the classic seismic world, felt events were believed to occur at magnitude 2 and greater, where you can feel the shaking at the Earth's surface. And we were certainly seeing that in the North Montney in that period. So we had numerous felt events, and that's where people report feeling something. But they were occurring at magnitude 3 and greater. For some reason so this is the part of the Heritage Montney, in the proximity of the Kiskatnaw River, we were seeing felt events at magnitudes that were not considered to be a magnitude where you should have felt events. So we were getting felt events reported even at magnitude 1.9 and 1.8. So there was something unique about that area that we hadn't seen anywhere else, and nor did the normal seismic experts identify that as a likelihood at that low magnitude that you'd get felt events. So there's something somewhat unique about that geology there. So we instituted an order, so a special order in that area. So again, amongst our regulatory tools, we can identify orders under Section 75 of the Oil and Gas Activities Act. We can put them in place pretty quickly. They are meant to deal with something happening on a specific area. So they're a special project order. And so we did that in the case of the Kiskatnaw area, Heritage Montney, where we were getting felt events at very low magnitude. And really, I'll have a bit of detail about that, but it was meant to have an enhanced focus by the industry, as well as enhanced communication with residents in that area who might be feeling these events. We also have, as part of seismic activity and induced seismicity, we put permit conditions in. We can put them in on individual permits. They can be customized to what we think may be happening in that area, and we do that especially around monitoring, the requirement to have ground motion detection and seismic monitoring arrays. And then what normally happens is as we learn from these orders or permit conditions, some of what we have in those become standard practice for every well. So then they move into regulation. So we've done that in the case of the seismic pieces of our regulation, where there are standard requirements to cease operations, as Jocelyn talked about in her talk, the kind of the traffic-like approach, monitoring, thresholds to cease operation, mitigation plans, startup plans, that type of thing. So this is the Kiskatna seismic monitoring order that we put in place that just identifies the area. It's roughly in the area between Dawson Creek and Fort St. John. But it really does require pre-completion notification of residents, identifies the submission of seismic monitoring and mitigation plans specific to that area and specific to each well. There's a notification component, and in that notification, residents are forewarned that this is a possibility, what it means, what they should do. We also require deployment of monitoring equipment, including ground motion monitoring equipment, in proximity to the well pad. And we have a reduced threshold magnitude where companies must cease operation and contact the commission and develop a plan before restarting. We also have a lower threshold for reporting, so 1.5 magnitude they have to report. Companies have been reporting everything to us anyway, so that hasn't really been an issue. We've been sharing information readily between ourselves, the companies, Natural Resources Canada and their seismic group. So it's been an area of study. We've got a number of, we've enhanced the monitoring array there in the NRCan monitoring stations in the Northeast. And then McGill University is also doing some study where they've added quite a number of monitoring stations for their research purposes. The only other thing I'd say about induced seismicity is, based on everything we know about the magnitude and the energy level associated with those magnitude events, we don't anticipate the likelihood of damage to infrastructure, whether it's residences, bridges, highways, that type of thing. And that's really driven by the amount of energy involved in a low intensity seismic activity, as well as the duration of the events. Building codes are put in place to withstand much more severe
Unknown participant is now joining.
forces like wind forces and so on than would occur with one of these events. And the last part I had was a bit on cumulative effects. It may overlap a bit with what Gary was talking about. So we did some work and do some work. This is from 2014. It reports, and it's available on the Commission's website. It reports oil and gas land use in the Northeast, broken down by the entire Northeast or by individual oil and gas basins, and by activity type, whether it's wells, roads, pipelines, geophysical. If you look at the Montney, at least up to 2014, the cumulative footprint was about 4% of the land base. Of that, half was historical seismic. So seismic footprint that no longer is practiced. They've moved away from that kind of high intensity or high footprint seismic to a low impact seismic. So we don't think going forward the footprint from seismic would look anything like that. So it would be a legacy footprint. And then roads are really, of what's left, roads are half of that. So the rest is wells, pipelines, facilities. We are tracking that over time. We're focused on not just the footprint impact, but also what that means as far as impacts on various environmental resources. And it's part of the overall focus on trying to come up with ways of assessing and managing cumulative impacts. This is some work that was done as part of, in the early days of LNG development in the province being talked about. This was a discrete scenario of what it would mean if we had a very aggressive development of I think it was 5 LNG plants at that time. It never came to be, but it was looking at what would that mean as far as wells to be drilled to fill those plants over time, and particularly given what we know about the productivity of shale gas wells. How many wells would you need? What would be the peak drilling period? What would it mean over time to sustain that? So this obviously is dated, and the aggressive LNG scenario never came to be or hasn't come to be. We did something similar around the footprint of wells, pipelines, and roads, looking at the incremental footprint over the baseline. And you'll see, what you see there is the incremental footprint, even in an aggressive scenario, was relatively small. Now, this was just a one-time scenario, but it was done not just as a hypothetical, but was looked at the actual likelihood of where activity would, where would we see development to provide gas for LNG plants. And really the reason that the incremental footprint is small is, and we're seeing that today, is when companies go in and develop a particular area, they usually build their processing facility first so they can monetize the gas as soon as it becomes available. But the other thing we see is when they develop the large multi-well pads, they build the entire pad for the eventual complement of wells they intend for that pad, but they don't drill them all at once. They drill, in most cases, only a quarter or less of the eventual complement of wells for that pad. So what we have now, and we'll see for some time into the future, is if future gas is required for LNG plants, it'll occur on existing footprint. It'll be infill wells. And there'll be a similar scenario, but not to the same degree, with pipelines and roads and so on. The province, ourselves, and the Ministry of Energy and Mines have developed a tool similar to what I think the concept that Pembina has, where you can adjust the variables and look at the footprint and water use impacts and other potential impacts. So you can really play with whatever scenario you want. So it duplicates this, but it's not just a single discrete scenario. And I think Gary talked about that. This is, again, looking at water needs, but same idea. But the current initiatives that we're part of and that the province is really leading is what Gary talked about, the Regional Strategic Environmental Assessment. It's a big focus for ourselves and the rest of government. Again, along with First Nations and other community members who are interested in the question of how do you assess and manage cumulative impacts. We also have a provincial cumulative effects framework. We have some regional assessments. I think in the Northeast, they're focused on grizzly bear as a starting point. And then in our case, as a decision support tool, although it's really kind of waiting for the regional strategic environmental assessment work to further itself, we have a support tool that's looking at, again, the parts of the oil and gas development footprint we control in our decisions.
Is now joining.
So that's all I have. Happy to take questions. Happy to come back at some future date if there are anything you want to hear more about that I talked about today, or something I didn't talk about that you want to understand better. There's many people in the commission more knowledgeable than I that I can send in place of me if you didn't think that I covered it well. But yeah, thanks again for the opportunity.
Just one, is there any evidence that seismic events are increasing in frequency or magnitude as drilling continues, or is it the same percent across from the beginning and starting?
No, we're not. I had the one slide that talked about it. We're not seeing any trend that way. It's really about if companies happen to be active in an area where there are those critically stressed faults, we'll see a cluster of activity. If they're not in that area, even though overall drilling may be increasing, if they're not in those areas, we won't see.
Evidence that drilling is contributing to the stress level.
No, as best, and I'm not an expert in it, but the faults that are causing the seismic events already are stressed from a seismic perspective. And the introduction of pressure and fluid allows them to slip.
Are the recommendations changing much?
Well, take everything I say as not the official province's. So what I'd say, if I recall, I think we determined there were 97 recommendations, although that wasn't entirely clear. Some people said there were 100 and some, whatever. Quite a number of the recommendations, I would say that they identified recommended actions to be taken that are already underway. So there were things that we were aware of or others were aware of that we were taking action on, and the recommendation just reinforced the need to continue that work, I think, more than anything. There were some recommendations, I think, that did raise some new subject area to work on. Again, I can't remember offhand exactly what they were, and I certainly wouldn't want to speak for the province's response to that. And then there certainly were a number of recommendations that I would say, based on the discussions I was part of, and I'm certainly not part of the main response, we would conclude that we've addressed that recommendation. But I assume it'll come out in the relatively near future.